Here we want to look at solving an absolute value where there's an absolute value in each side. So before we do this actual one, think about the reason why this works. Is if I'm trying to get the absolute value of two things equal, like say absolute value of 3 equals absolute value of 3, that would just say 3 equals 3. But absolute value means the distance from 0, so if I had something like absolute value of -3, which is 3, equals absolute value of 3, which is 3. So these two numbers both have the same distance from 0, so their absolute values are equal. So notice if I look inside the absolute values, I don't need them to be perfectly equal. They could be perfectly equal, or one could be negative and the other one's positive as long as the digits are the same. So what can I do to model that up here? Well, that means I'm going to have two different solutions. Either I could get 2u plus 6, so what's inside one absolute value, to just equal exactly what's inside the other absolute value, or I could get one absolute value to equal the negative of the other one. Be careful, whichever side you make negative, it's that whole side. So the minus is on the 2 and on the -3. So it makes one whole side negative. All right, here if I subtract 2u from both sides, I just get 6 equals 3. So that tells me, at least that route, and this won't always happen, but that route comes up, there's no solution coming from this piece. But what about our other half of this? This could give us a solution, or this could give us a solution. Now we're adding 2u to both sides to get rid of a -2u. So this says 4u plus 6 equals -3. And then subtract 6 from both sides. So I get 4u equals -9. And divide both sides by 4. And so a lot of times you get two solutions. Sometimes in this case you can get one solution because this one came up no solution and this side gave us one. But mainly it's that when the absolute values are alone, you split them. It could be equal or one side could be negative. Make the whole other side negative if you do that.